So today I will discuss some previous year questions of class 10 as pre-board exam is coming, and in February there will be board exam. So I have chosen some moderate to hard level questions and also critical thinking questions involved. So you can see this first question. First note down this question, then I will solve its answer. Find the zeros of the following polynomial 5 root 5x square plus 30x plus 8 root 5. So this is your polynomial. Now we have to find its zeros. Means for what value of x this polynomial value can be 0. So for this type of equation, first what we do, so I am doing here solutions. Okay, so first we write the polynomial 5 root 5x square plus 30x plus 8 root 5. Now I have to find its zeros. That means I have to get the value of x for which this value can be, this expression of the polynomial can be 0. So first step, first we will equate the polynomial with 0. Okay. Now this is an equation, you have to solve it for x. So we can do middle term factor. So here our terms are 5 root 5 and 8 root 5, right? So 5 root 5 and 8 root 5 means this is 40 into 5. So this is basically 200. So somehow, because there is plus sign, so somehow we have to get multiples, means we have to factor it 200 in such a way that we'll get 30. So 200 equal to 20 into 10, right? And also 20 plus 10 equal to 30. So I can write 20 plus 10 here. Okay. So 5 root 5 x square plus 20 plus 10 x plus 8 root 5 equal to 0. Now expand this expression. So 5 root 5 x square plus 20x plus 10x plus 8 root 5 equal to 0. Right? So this side you can write as rough. Now there is grouping I can do. These two can group together, these two can group together. So from these two I can take common 5 root 5, right? So 5 root 5 I can take common. Also an x will be common. So 5 root 5x. So here x, here 5 root 5 I have taken. So 1 5 get out. Okay, so root 5 I cannot take out, right? Okay, so I have done one mistake. Root 5 we cannot take it out. So we can, because in 20 there it is 5 into 4 only, right? There is no another root 5. So I can take common only 5. So I have take 5 common, and also x we can take common. So here will be root 5x. Here 5 is common, x is common, 4 is left, right? So here 10 8 root 5. So here is any root 5. 10 means what? 10 means 2 into 5. So basically 2 I can take common, and also root 5 I can take common. So 2 root 5 I can take common. Then here will be 2 root 5. So here root 5 is left, root 5x plus root 5 I have taken common from 8 root 5, and also 2 is taken common, so it will be 4. Okay, so here I have got the same terms, same expression the same expression in both these terms. So now take common it. Root 5x plus 4 I have taken common, then it is 5x plus 2 root 5, right? So we have transformed the polynomial, the equation, into factors. Okay, so now we can solve for x. So root 5x plus 4 equal to 0 implies x equal to minus 4 by root 5, right? And here x equal to 5x plus 2 root 5 equal to 0. So implies x equal to minus 2 root 5 by 5 implies x equal to minus 2 by root 5, right? So we got two roots, so that is we have two zeros here, two zeros of the polynomial are minus 4 by root 5 and minus 2 by root 5, right? So we have got the answer of question 1. Okay, now we can see what is the second question. Second question is find the quadratic polynomial and whose zeros are reciprocal of the zeros of the polynomial fx equal to ax square plus bx plus c, right? So means we have a quadratic polynomial. Quadratic polynomial is this given, but we have to find a quadratic polynomial whose zeros are reciprocal of these polynomial zeros. Okay, so first we have to let something. First we have to let. So second question answer. First note down the question. I am giving some time to note down it. Note down the second question. In case you didn't write, finish it, just pause the video and just note down it, then again come to the solution. Okay, so second question, first you have to let the zeros of the polynomial fx equal to ax square plus bx plus c are alpha and beta. So I have let that alpha beta are the zeros of the polynomial ax square plus bx plus c. Now basically we have to find a polynomial. So we have to find a polynomial whose zeros are one by alpha and 1 by beta. Okay, now we know that when we are deriving relation between roots and coefficients, we got that the polynomial equation, the quadratic equation, can be written as in terms of two roots, right? So that thing is x square, if you can recall it, x square plus minus alpha plus beta x plus alpha beta. I think that you have already read. With this type of form we can make, right, for a quadratic equation. But here, so basically, and from that we got the relation that any two roots sum is equal to minus b by a. If it is the standard quadratic polynomial, actually it is standard quadratic polynomial, so alpha plus beta into minus b by a, you can recall this formula, and also alpha into beta equal to c by a. Okay, so this is the formula of relation between roots and coefficients. So these are the formula, and this formula got from this equation, this one. So basically here I have taken alpha plus beta. So this is true, right? Alpha plus beta equal to minus b by a, alpha beta equal to c by a. Now if I find a polynomial whose roots are 1 by alpha and 1 by beta, so in that case your root sum, what is the root sum I can define? 1 by alpha plus 1 by beta. So I can do simplified alpha beta, beta plus alpha, right? So what is alpha plus beta value? From this equation, this is given, and this is a standard form, and we got that formula, but actually a standard form. So you got that alpha plus beta equal to minus b by a. So here I can write minus b by a, okay, and alpha beta is c by a. So minus b by a into a by c, so we can cancel out a, so we have left with minus b by c, right? So we got 1 by alpha plus 1 by beta. Now, so quadratic equation is in this form, right? So is in this form, so alpha beta we also needed. Alpha beta means product of the roots. So product of the roots are needed. So here roots are what? 1 by alpha into 1 by beta. So their product is 1 by alpha beta. So what is the value of alpha beta? C by a. So I can write a by c. Okay. So now I can write a polynomial whose zeros are 1 by alpha and 1 by beta. Zeros are actually roots. So sometimes you can call it zeros, sometimes you can call it roots. So the required quadratic polynomial is so x square minus 1 by alpha plus 1 by beta x plus 1 by alpha into 1 by beta. Okay, so x square minus b by cx plus a by c. So this is your equation, this is your polynomial, sorry. Now you can take common c. So if you can recall it properly, this expression at the first you can write a constant here. Okay, you can write here a constant, and that is the general form. So here you will take also a constant because c is in the denominator, so you can take common the constant c. So in that case cx square minus bx plus a. Okay, So one thing that this is minus, oh sorry, this is minus, and also 1 by alpha plus 1 by beta equal to minus b by c we got. So minus minus it will be plus, right? So it is plus. So cx square plus bx plus a. So your required polynomial is this one. Maybe you will get this one in option because a constant, one constant can be outside the first bracket. So your polynomial is this one. General form is this one, k into x square minus alpha plus beta x plus alpha beta. The relations are alpha plus beta equal to minus b by a and alpha beta equal to c by a. These formulas are very important. So I can see if there is any kind of option. So there is no option given. So your answer is here, cx square plus bxa is your required polynomial. Okay.